Right, we're going to pick up where we left off, and we're looking at 10C. Here we're asked to find the probability that a student is male and 18 to 20 years old. Remember that an and is an intersection, so we're looking at where they cross. So we would name this male and 18 to 20. And my denominator is going to be 36. And if I scroll back up to the top of my table here, here's 18 to 20, and here's male. And so the value they share is this 10 right here. So I'm going to put that 10 on the top of my fraction, and then I'm going to reduce that down, dividing both by 2, gives me 5 over 18. And for now, I'm going to go ahead and stop there. Remember that you can put that into your calculator to find your decimal equivalent in percentage, but I want to make sure I'm keeping these videos fairly short. So the next question asks us to justify. Guys, when it tells you to justify, you're going to have to prove using your independence rule. We're trying to figure out whether being a woman and being 18 to 20 are independent events. So this is a key here. That means we're going to be using the rule that the probability of A times the probability of B equals the probability of A and B. Now, you don't have to list everything back out again, but you should label for me which one is which. So I'm going to say being a woman is event A. And so I'm going to put that information right here. I know there's 36 people in the class. And again, if I pop back up here, in that class, 18 of them are female. So I'll use that 18 as my numerator. And then I'm going to find the probability of B. For me, I'm going to call B being 18 to 20. So again, that's out of 36. And if I scroll back up here, ages 18 to 20, we had 20 of those students. So I'll use that number right there, the 20. And if I'm doing this correctly, it should equal the probability, oops, I forgot to label this as B. Oops. This should be the probability of A and B. So I should have the probability of being a woman and also being 18 to 20. So I should have this piece still out of 36, but what I'm going to look for is that overlapping. So I'm going to look to see where being 18 to 20 and being female cross each other, and they cross right here at 10. So that would be my last numerator here. And my job is to test this multiplication problem and see whether or not it's true. So if I was to put this into a calculator, the left side, I'm not going to even mess with the right side now, but if I was to put 18 over 36 times 20 over 36 in my calculator, and make sure you guys can all see this, what I get is the reduced fraction of 5/18. And so I'm going to just, I'm going to write this direction. So A times B, I'm shorthanding a little bit and not using my probability note, gave us 5/18. And then I would do over here A and B. And so if I put that 10 over 36 in my calculator and it reduces it for me, I'm going to also get 5/18. So in this case, since that is a true statement, yes, that's true, we would say that these two events are independent. If this was a false statement, if one said 5/18 and one said 2/3 or whatever it might look like, then we would say that they are not independent events. But in this case, being a woman and being 18 to 20 have no relationship in the class. I'm going to pause so you can try example J and then check your work. Okay, so here's example J, A and B. So you can check those are final answers only. Check those. And then if I turn it over, JC and JD are here. There's female and no credit. And this is my proof for independence. I did my multiplication here, my overlap here. These are not the same and therefore not independent. All right, we're almost done here, kiddos.